Hey guys, welcome back. This is Professor Hank, and in this video I'm going to give you a brief introduction to classes in Python. So specifically we're going to talk about four things here. I want to show you the basic syntax for defining a class. I want to show you how to add methods and variables to that class. I'm going to talk about two special methods, the init and stream methods. And then we'll finish off with a brief discussion on private versus public attributes. Textbook that we use at my university mangles this discussion quite a bit. So for the benefits of my students, I'm just going to try to clarify a little bit, make it a little bit easier for them to cut through some of that confusion. All right, so let's go ahead and get started. Okay guys, so in this video I'm going to walk you through the different pieces that I mentioned in the intro by writing a class that I'll call rectangle. And the rectangle class will represent our rectangle, and it's going to include attributes for the length and the width of the rectangle, as well as appropriate accessors and mutators for setting and getting values out of those attributes. And we'll also include an initializer, we'll include the stream method, and we'll include a getArea method, which will find the area of the rectangle by deriving the area from the length and the width attributes. Okay, so let's go ahead and get started. We're going to need a new keyword, and that keyword is class. Okay, and in addition to that, we're going to need to set up a name for the class, right? And so the name for the class follows the same rules as any other identifier within the language, right? So anything you could name a variable, you could name a class, but by convention, class names are usually capitalized, right? So let's go ahead and get the rectangle started. So I'll say class rectangle, okay? So class rectangle. Now everything that is part of the block following that header, everything that's indented is going to belong to that class. Okay, so let's start by adding a method for setting the length and method for retrieving the value or retrieving that length, right? So the syntax here is going to look very similar to defining any other function that you've seen before. We're going to have that def keyword, and then we're going to have a name. So I'll call this set length, right? We'll do the length first, okay? And we'll call it set length, and we're going to have a parameter list just like any other method, right? Now, or just like any other function. Now, what's going to be different here is that no matter how many arguments you want your method to accept, you're going to always include one more, and that is going to be this parameter right here, self, okay? So the self parameter, it's going to have the memory address of the object that's been instantiated from this class, okay? So it sounds a lot more complicated than it is. Just know that you always have to include it, and it's how we're going to differentiate between variables that belong to the object, which are an instance of the class, and variables that would be local variables, okay? So we'll make this L for length, okay? And so inside the body of the method, I'll just do something like this. We'll keep it really simple. We'll just say self dot underscore length equals L, okay? More on the underscore thing here in a little bit. Okay, so this particular method is going to assign its argument to right here. It's by saying self dot, we're saying that this underscore length method is the method that belongs to class rectangle. It's not a variable that's local just to set length as say L is, but it belongs to the entire object. And so its scope is going to be the entire rectangle, right? Whereas L here is a local variable just for set length, okay? So now let's go ahead and include another method, which we'll call getLength, and all that's going to do is return the contents of that same variable, okay? So methods that change the object in some way right? And remember, an object is just an instance of a class, right? It's just the actual built house. If class rectangle is the blueprint, then an object is an actual house built based off of that blueprint. Okay. So anyway, set length is a mutator because it can change some aspect of the object. Okay. So length belongs to the rectangle, and so we're changing that. So set length is a mutator. Get length is an accessor, because all it's doing is returning a variable that belongs to the rectangle. Okay, so we're going to need set length and get length. Now, before we go on much further, let's go ahead and define a main function, and we'll instantiate a rectangle, right? So when we actually want to create one of these things in memory, with our class definition here, what we're doing is we're defining what a class is, what it can do, what it's supposed to know, and what it's supposed to be able to do. But this doesn't put anything in memory just yet. We actually have to create an object that is an instance of rectangle. So we'll have to do something like this. Okay? So that will create an instance of rectangle. Now this is going to cause two things in memory to get created. Right? The R is a variable that's going to hold the memory address of the object that's been created by this second piece right here. So line 19 causes two things to be loaded into memory. Okay, now we'll call main. Okay, and then we'll try to run this thing and see if I have any crazy mistakes just yet. Okay. Okay, so cool, no syntax errors just yet. Now, how do I want to use this thing, right? Well, what I can do is I can say, right, well, r dot set length, and now there's two parameters here, but again, this is only going to take one argument. Okay, self is always included for every single method, but if you want to accept arguments, you have to include additional parameters, and that's this L here. So you can, when it comes time to invoke the method, just forget self even existed. Right, so we'll set the length to, I don't know, 8. Good enough, right? And then what I'll do is I'll call get length, and I'll pass that to the print function, just so we can see the results. Okay, so you can see the output there, 8, right? So we stored 8 inside of the rectangle. Now we're not done yet, because we only have the length for our rectangle. We need to add the width too, so we'll do that. Set width, and we'll call this W, and we'll say self dot underscore underscore width. Again, I'm going to explain these underscores here in just a second. Before we're done, we'll explain them. Okay, now let's have an accessor for that. Get width. Now you can have as many parameters as you want, right? It's just for this particular example, I don't need more than what I'm doing here, right? So don't think that you're limited to having at most 2 parameters or whatever. You can have as many as you need, just like any other function. Okay, so let's, oops, that's supposed to be, yeah, that's right. So get width, right? So self width. Okay, cool. All right. So let's go back down into our main function, and we'll set the length again, or set the width this time. Set width, and it's just convention to name your methods, kind of like what I've done here. Set underscore width, because accessors and mutators are often referred to as setters and getters, or set methods and get methods. You can name them whatever you want, as long as you follow the usual rules of identifiers for Python. Okay, so don't think that you have to prepend the names with set and get or whatever. Okay, all right, so get width. So let's run this one more time. Okay, so now we can see that the 8 and the 4 are stored inside of my rectangle. Okay, so one more thing that I wanted to do here, well, a couple more things, but what I'm going to do here is I'm going to create a method called getArea, and all this thing is going to do is return the product of width times length. Okay. So what this is going to do is it's going to take whatever width and length is currently set to, multiply them together. That's going to be your area. Okay. So let's go ahead and call that. And you'll notice, for the get area method, get width method, even though there's this self parameters here, I'm not passing any arguments, right? That's just kind of the way it works. By having this self here, you're saying, no, this is referring to the object itself, right? So width belongs to the rectangle. Okay, so let's go ahead and test that, right? So you can see the 32 on the last line of output, right? So you can have local variables. There's nothing stopping you from doing that. So I can say area equals, self dot width times self dot length, and then return the area, right? And that's going to work, just fine. So the difference is that since area here doesn't have that self in front of it, the scope of area is just get area, right? Whereas since the self is in front of the underscore width and underscore length, their scope is the entire class, right? All the methods for the object can access them. Okay. All right. So now, let's say that I go back here and I initialize another rectangle, or I instantiate another rectangle. All right. Let's see what happens here. Say s equals rectangle. And then we'll go ahead and we'll call s dot get area, and we'll just try to print that out. Let's see what happens. Okay, bleh. Got ourselves a problem here, right? Why? Well, if you look at what's going on here is the problem with this is because of line 40 here, right? Why is this an issue? Because since I didn't call for the second rectangle, whose memory address is an S, since I didn't call it set width and set length methods, the width and length variables were never created for this second rectangle, right? And so that's why this is all freaking out here. Okay, so what we would have to do is we'd have to make sure to call s dot set length, s dot set width before we call any of our accessor methods, right? But that's kind of annoying, right? And so what we can do instead, what's better, would be to set yourself up an initializer method, right? Now an initializer is also a mutator because it does change the object, but it's special, right? So an initializer is a method that gets automatically called when you create the function, right? Or when you create the object, excuse me. So it has a special syntax, right? So you say def, and then you take two underscores, like what I did with length and width, and then you type in it, and then you have two more underscores, and then you do self. Okay. Now, in here what you do is, now this method is going to get automatically called, right? When you have a line like line 32 here, you have a line like 42, the initializer gets called automatically. You don't call it. You don't say dot, underscore, underscore, init, underscore, underscore, like you do with get width or the set width. Okay, initializers are automatic. And they have this special syntax. There's the keyword for init, and there's also the underscores. That's part of the syntax. They're special, okay? So what you can do in here is say, all right, well, let's go ahead and create our length variable and set it to 0. And then let's create our width variable and set it to 0. So now, whenever you instantiate a rectangle, whether you call it set length or set width method, you're going to be good to go because the initializer is going to create them for you, right? So now, if I go in here and run this thing, no problem, right? Because now line 44, when it does get area, returns 0. Why? Because the initializer for this second rectangle, right, it set both the length and width to 0, right? Now, did that for the first rectangle too, but immediately afterwards on line 35 and line 38, we overwrote the zeros with 8 and 4. Okay. Now, what if I wanted to, when I instantiated my rectangle, if I wanted to initialize the rectangle with something other than 0 and 0, right? Well, then I could have a different initializer, right, that has multiple parameters, right? So what I can do now is I can say, well, self underscore length equals L, right? And then I could say self dot underscore width equals W, okay? Now, if I do that, then let's go ahead and test it, okay? Now, if I do that, I have some issues here, right? In that I have an initializer that requires two different arguments, right? And so that's what this is complaining about right here, is that on line 37, right, which is right here, it's saying, wait, where's my two arguments, okay? So if I'm going to do that, then what I have to do is I have to go in and I have to pass a couple of arguments here, right? So that way that 3 and that 2 get into the L and get into the W, okay? So let's do that. Let's fix that. And let's try it again. Now, got another issue, right? See where it says S equals rectangle? Same thing, right? So I have to provide, arguments for that initializer. So let's plug those in. So let's say 4 and 2, okay? So let's run it now. And you can see that for the last rectangle, there's the get area, which is 8. So I initialized length and width to the arguments that I passed to the initializer, okay? So that's something to note. And another thing that you might note, for those of you, who maybe a little bit of experience programming, I wasn't able to overload the initializer, right? This guy right here didn't get a chance to execute. I'm going to have to do one or the other here, right? So I'll either have an initializer that's going to take some arguments, or I'm going to have an initializer that doesn't take any arguments, right? So either this is going to set my rectangle's length and width to 0, or I'm going to have an initializer that's going to set my rectangle's length and width to the arguments. Okay, so since I have this initializer with the two arguments, I'll go ahead and get rid of this guy right here. Okay, and I will include one more method, which is going to be the stream method. Okay. Now the stream method is another special guy, just like the init is special. So maybe we should put them at the big front, put them at the beginning. Right. Now all this method is for, it's supposed to return a string representation of the object, right? Whatever that may mean to you as the programmer programming the object. So I might just decide, well, what I'm going to do is I'm going to take a string version of length, and I'm going to append to that maybe an X, so that way I can say like 4 by 2 or something like that, the dimensions of the rectangle. Then I'll say string self dot width. Okay, so now what's going to happen is that I can just return that, or I can assign it to a local variable first and then return that local variable. And let me put this on separate lines so that way you can see it. So now this guy right here on line 10, special method, its purpose is to allow me to pass the reference, so in this case the S or the R, right? Pass that to the print function, and then the print function will automatically call the stream method here. That's how it's usually done. Okay, so let's try that. Let's see, what did I mess up here? Oh, my indentation, right? So we're continuing our line. So, and we need our line continuation operator, which we'll put right there. Okay, so there we go. Now 4 by 2, right? Because why? Well, this is the 4, right? This is the x, and then this is the 2, right? So that 4 by 2 was the result of my rectangle object right there, right? And this guy right here. Now, that's kind of gross. I mean, I think it looked better if I had spaces on either side. So let's do that. Maybe it still sucks. I don't know. Whatever. All right. So I think there's one last thing that I wanted to tell you. Right. Let's make a note here. Returns a string representation of the object. Okay. So anyway, one more thing here, right? There's this whole idea of private versus public, and our textbook talks about, the stuff should be private. Textbook here kind of screws this up pretty hard because in Python there actually isn't this concept of private versus public. I mean, in object-oriented programming, it's a thing, and it's a big thing. But in Python, it's not something that's enforced by the interpreter, right? So when I put these double underscores in front of length and in front of width, what I'm trying to say is that, hey, length is private, okay, and width is private, okay? So no client code is supposed to be able to directly access or manipulate those variables. Okay, and I mean, there's this whole concept known as name mangling in Python, which the textbook doesn't go into at all. But essentially, everything in Python is public, and this whole idea of doing private and public, it's more of on the honor system and a convention, right? And I'll just leave it at that. I think I would need a whole other video to explain that in more detail. So the reason I'm doing these double underscores for width and length is just to let the reader know, these things are supposed to be private, right? You shouldn't be accessing them directly. You should be going through their appropriate methods, right? So to set length and get length, and set width and get width. Okay, so let's just go ahead and summarize what we talked about in this video. Try to keep it as short as possible. Python classes in 15 minutes, right? I mean, there's a lot more to it than this, but this should be enough to get you going. What I wanted to show you was, how to define a class, how to, add methods and variables to that class, what the syntax looks like for that, how to instantiate a class, create an object based off of that class, how to invoke the methods. Showed you what the init and stream methods do. Remember, you can only have one init method in Python that's gonna run for you. And remember, the stream method is for creating or returning a string representation of the object, whatever that may mean, right? And so, also don't forget that your class is a blueprint that defines what an object is going to be and what it can do and what it's going to know. And the object is an instance of that class, similar to how if you have a blueprint for a house, you got one blueprint that defines what that house can be. But you could have many instances of that blueprint. You could have many copies of that blueprint manifest as a house, right? So you can have 20 different houses based off of one blueprint, right? So in that analogy, the houses are objects and the blueprint's a class. Okay, and so last thing we talked about was private versus public attributes. Long story short, everything in Python is, at the language level is public, right? There's no strict enforcement by the interpreter for public versus private stuff. There's no syntax built into the language. The underscores are a convention. There's some other stuff there too, but basically they're a convention that just says anybody who's using your code should look at that and go, okay, I should go through if I'm going to use your code correctly, if I'm going to use your classes, then I should be using the methods and not this private stuff. So it's more kind of like a wink, wink, nod, nod between programmers in the Python ecosystem, or in the Python culture, whatever you want to call it. In other languages, though, it's a strict, adhered to kind of thing where you have your own keywords for private, public, protected, all that kind of jazz. But for Python, it's more kind of like a gentleman's agreement that if I make stuff, I'm letting you know if you see any of my methods or any of my variables that have underscores in front of them, you shouldn't be you shouldn't be calling them directly. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.